Okay, so time for a new lesson. Come on, let's get the camel out of the way. I don't know why they're doing a camel here. Another camel. Do. Got no clue what these camels are doing here other than creating a roadblock. Okay, it is our third lesson of this unit. We're going to write an expression for the nth term of a geometric sequence. All right, first lesson, I just kind of gave you some equations and you created a sequence by plugging numbers in. Second lesson, we looked at an arithmetic sequence. And now with this third lesson, we're looking at a geometric sequence. Now, if you remember, the arithmetic sequence was an adding pattern. Geometric sequence is a multiplication pattern. So we're always going to multiply by the same number again and again and again. The expression for the nth term of a geometric sequence, a sub n equals a sub 1 times r raised to the n minus 1 power. A sub 1, of course, is the first term. In other words, the first number in the list. And r is the common ratio. In other words, what we multiply by each time. So let's do a few examples. All right, so there's a sequence, right? It looks like a list of numbers. Most normal people say, hey, list of numbers, but a mathematician would say, oh, a sequence. Well, it looks like we multiply by 2 every single time, right? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So, okay, I see the pattern. We keep multiplying by 2. So the common ratio, r, is going to be 2. The first number in the list is 3, right? So a sub 1 equals 3, right? That's the first term in the sequence. So I'm going to write down my equation. The nth term, right? That's a sub n. The nth term of that sequence will be equal to the first term times the ratio, where the ratio is raised to the n minus 1 power. So, a sub 1, well, the first number in the list is a 3. Plug in a 3. R, well, the ratio is 2. We keep multiplying by 2. Plug in the 2. And can we simplify this? No. Right? If you want to try to do 3 times 2 is 6, we're not allowed to do that because the 2 has an exponent, right? N minus 1 is an exponent. So since the 2 has an exponent and the 3 does not have an exponent, there's nothing we can do. We're done. That's the answer. Okay, new example, new list, new sequence. 243, 81, 27, 9, 3. So we keep multiplying by 1/3. Now, if you're thinking that we're dividing by 3, you're a pretty normal person, but a mathematician would say, no. We're multiplying by 1/3. Now, if you're looking at 243 and that 81, you're saying, I'd never figure out that's 1/3. Look at these two side-by-side numbers. Look at the 9 and the 3. I can take any 2 consecutive terms in that sequence, and I say, oh, 3 over 9? That reduces to 1/3. I was multiplying by 1/3 every time, right? 243 divided by 1/3 is 81. 81 times 1/3 is 27. But again, take a look at easier numbers. Look at the 9 and the 3. Say, aha, that 9 shrunk down to a 3. So I got 3 9s, that reduces to 1/3. So the ratio is 1/3. The first number in the list is 243. I write down my equation. The nth term equals the first term times the ratio to the n minus 1 power. A sub 1 is 243. Ratio is 1/3. And again, I am done. That will not simplify. That's the answer. Let's do a couple more, and then I'll cut you loose. 2, 10, 50, 250, 1,250. Okay, 2 times 5 is 10. 10 times 5 is 50. Okay, we keep multiplying by 5. We're multiplying by the exact same number every single time. Keep multiplying by 5. The first number is 2. Write down the equation. First number is 2, so plug that in. The ratio is 5. Plug that in. We're done. That's the answer. That's the equation that creates that list of numbers. 81, 54, 32, 6, 24, 16. Now again, if you're looking at an 81 and that 54, you're like, I'll never figure this out. Well, spoiler alert, it's 2/3. And the easiest way, look at the smaller numbers in that list, right? Look at the 24 and look at that 16 and say, oh, 16 over 24. Can I reduce that fraction? Well, 16 is 8 times 2. 24 is 8 times 3. Common factor 8 cancels out. Sure enough, I got 2/3. All right, so again, don't look at the 81 and the 54 and panic. Go down the list a little bit and get some numbers that aren't quite so large. Say, oh, 16 over 24, I can work with those. First number is 81. You know, the ratio is 2/3. So let's put together an answer. The nth term of the sequence is 81 times 2/3, where the 2/3 is being raised to the n-1 power. That's the answer. We're done. Right? We did 4 examples here. And, oh, I wonder if this is going to spell out worksheet. Oh, big excitement every time. And, oh, that might explain the camels from the first slide. It looks like we're somewhere in a beautiful sandy desert with a bright blue sky. That would be a wonderful place for the camels to hang out, I bet.